Okay, so last week we learned how to add and subtract polynomials. And this week we're going to learn, number one, how to turn on the TV so you can see what I'm doing. And number two, how to multiply polynomials. And we're going to start off by learning how to multiply monomials and binomials. So in this problem that I wrote right here, the monomial is the part that is out in front of the parentheses. A monomial is a polynomial with only one term. Now this term is just a constant, -4, but a monomial could also include a variable, like instead of a -4, that could be an x, or it could have both. -4x is also a monomial. But in the parentheses, this is a binomial. It has two terms. You can count how many terms a polynomial has by looking for the plus and minus signs. If there's a plus sign or a minus sign separating them, that is two different terms. So this is a binomial because it has two terms, and a monomial because it has one term. And the reason this is multiplication is because of these parentheses. The parentheses are another way of writing multiplication. So in between the -4 and the x minus 5, since I have parentheses, that is telling me to multiply. If you multiply without actually writing a multiplication symbol like a dot or an X, that is called implied multiplication. Implied, because we don't actually write it, but we mean to multiply. Multiplication is the only operation in math that you can do without actually writing the symbol. Plus, minus, divide, you got to have the symbol, but multiplication, we're a little more lax about it. So in order to multiply this problem together, we're going to use the distributive property. The reason that we know we need to use the distributive property is because we have a set of parentheses with a term outside the parentheses. This definition of distributive property, I'm going to rewrite the problem over here since I kind of marked it up the first time. The distributive property, thank you, sir. Oops. Okay, awesome. The distributive property just means to take whatever is outside the parentheses and multiply it by all the stuff that's inside the parentheses. So I will take this -4 and multiply by x. Now, if you know that that is -4x already, you can just write -4x. And I'm going to go ahead and write out -4 times x. There's my first step. My second step is going to be to do -4 multiplied by -5. -4 multiplied by -5. And I'm just going to add these two things together. Now, this step right here that I just wrote, this is like an optional step that you don't have to write out. In fact, after you are multiplying for a while, you're going to get where you don't need to write it out. I'm just doing it the first time so you can see exactly what we're doing. So we've got -4 times x. What is -4 times x? Good job. Plus, what is -4 times -5? You're all good. -4 times -5. It's like a ½ second delay whenever you have your volume turned on. That makes it sound like I'm echoing, like I'm talking through a megaphone. You are so close, Catherine, but a negative times a negative is a positive, so it's +20. Very good. Cool. Now, the last question that I would ask myself is, can I combine -4x and 20? Can I add those together? Are they like terms? And the answer is they are not. They are not like terms, which means I cannot combine them. Can someone explain to me why these aren't like terms? Exactly right. The first term has a variable, x. The second term does not have a variable. They cannot be added. Notice that it's totally fine for me to multiply unlike terms. I just can't combine like terms. So the answer to this problem is Negative 4x plus 20. Can I pause for a second because you didn't start on time?
I'm sorry. While you're waiting for her,
I'm not waiting for her. Do I look like a waiter to you? Sometimes. I wore a cummerbund and a bow tie one time. All of a sudden, everybody thinks I'm a waiter. If you really are behind on the notes, I will send these to you once we're finished. I'll email the notes to you. So again, this is a monomial multiplied by a polynomial. This time we're going to be using our product of powers rule, though, which we learned last time, because whenever we do the distributive property, the very first thing that we do is multiply two things together that both have a variable. Now they have a variable, but the variables are different powers. That's okay if we're multiplying. It's okay to multiply unlike terms. It's just not okay to combine unlike terms. So we can still do this. We can do the 6y cubed and the negative 5y multiplied together. So it'll be 6y cubed multiplied by negative 5y. And then we'll distribute to the second term, the 3. So 6y cubed times 3. And what will we do with these two results? We will add them. It's always addition in the middle if you do it this way. Always addition in the middle if you write out the step there that I wrote. Okay, cool. So 6y cubed times negative 5y. We're multiplying constants and we're multiplying variables. So let's break this down. Yes? Good. First we multiply the constants. 6 times negative 5 is negative 30. Y to the 3 times 1 is 3, but we're multiplying the y's. We're not multiplying the exponents. So you add them. So y to the 4th spectacular plus 6y cubed times 3. Say it again. 18, because 6 times 3 is 18. And it's just y to the 3rd because we're not multiplying by anything else with a y. Are these like terms? Are these like terms?
No, just stop.
They're not like terms, but they are like terms.
Well, the powers aren't the same.
The powers are not the same. Different exponents means I cannot combine them. So this is my solution, children, just like that. I know this answer looks ugly, but remember, real beauty is found on the inside. At least I hope it is. I'm going to give you a minute or two to try to do that one on your own while I answer Peyton's question. Try that for just a second.
It's like the love stuff. Like you're born. Basically like.
If I had to guess, and I do because I'm not out of class, I would say the second time it would take is the most important thing for you to know. How long is it going to take us to get there? I think that's important. Oh, somebody's putting spoilers in the chat. That's Brock. Dang it, Brock. Brock's in algebra. He should definitely join the math team. Look how fast he is. He would be an excellent math team member.
We're not as scary as we seem.
Wait, can you not, I have a question. Can you not, if the two has a variable, and we're doing distributive property, do you not multiply it by, not multiply the two without the variable because it doesn't have the variable?
You can multiply if one has a variable and one doesn't. You can multiply, you just can't add.
Well, I think I know it, but I click the variable.
Well, the first thing we'll do is 2x times x. And then we'll do 2x times -2. And we'll add them together. What is 2x multiplied by x?
Or would it be
It'd be 3x if I was adding them.
multiplied?
What's x times x? X squared. You were close. Okay. Then 2x times -2. Remember, numbers first, then variables. So 2 times -2. Mm-hmm. -4. And what about our x? -4x. Can I combine 2x squared and -4x? Right, different exponents. I could write 2x squared plus -4x. There's not anything wrong with that. Or I could do 2x squared minus 4x.
Can we always do this, even if it's subtraction we add, to make it addition?
If you do it the way that I'm doing it, which is writing out the two things multiplied together and then multiplying them, then yes, you can always put a plus sign in the middle. But you may notice that if I just done 2x times x and then 2x times -2, I could have gone straight to 2x squared minus 4x because 2x times -2 is -4. So either way is correct. Now where things get a little tricky is when we multiply two binomials. Por ejemplo, 2x minus 1 and x minus 4. So now it's getting crazy.
You should try after this break. You should try to talk for Spanish for 15 minutes straight. Yes.
And we can't use distributive property because the both
That is a really good question. The question was, can we use distributive property if we've got two sets of parentheses? And the answer is, yes, you can. Yes, that's an excellent, excellent technical definition. You go whoop, 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 whoop. Okay, everybody got it?
Well, how do you do it then? Because usually when you do distributive property, you multiply the number outside the parentheses.
Very good. So what we have said previously about distributive property is you take whatever's outside the parentheses and you multiply by the stuff that's inside parentheses. But this time, kids, there are two things outside the parentheses. We've got a 2x outside the parentheses, And we have a -1 outside the parentheses. What? So what we're going to do is we will take the 2x and multiply it by x minus 4. And then we will take the -1 and multiply it by x minus 4. Both things, the 2x and the -1, are going to get multiplied by the x minus 4. It's crazy. Very good. So Shelby's already multiplying for us. 2x times x is 2x squared. Good. 2x times -4 is minus 8x. So Shelby is now a professional at multiplication because her math teacher is so great that she is not even writing the in-between step where we did 2x times x and 2x times -4. She's just going straight to the answer like a boss, as the kids say. Okay, now let's do distributive property here. -1 times x is -1x, or just -x. -1 times -4 is, oh my gosh. I am so proud. I have done such a good job of teaching this to you. I can't believe at the beginning of this lesson, not only did you not know how to multiply these, but you didn't even speak English. And now, fluent English, awesome at math. I've only been going for like 10 minutes. I should get an award.
You should become a teacher.
A lot of people told me, like, you should be president or richest man in the world. But I was like, no. I know where I'm really needed.
I want to make an impact on people's lives.
And then we add those together. I mean, you didn't say positive impact, but it's
An impact on kids' lives. They'll remember me forever as the one that made them hate learning. So when we look at this 2x squared minus 8x minus x plus 4, the question we want to ask ourselves is there anything I can combine? I know I can't combine all of it because some of it's x squared and some of it's x and some of it's a number, but is there anything in there, any like terms that can be combined? The answer is yes. What are they?
-8.
Why do you hurt me? Yeah, the x's. Those are the like terms, the ones with x's. So the 2x squared gets no love. What's -8x minus x? You're not even in this class and you're getting it wrong. Amazing. -8x minus x. If you say -7, you're actually going to make me cry. -9x, thank you. Thank you, a person who's not in this class. And then on the end, plus 4. Okay. Now that we've combined the like terms, the x's, is there anything in this that can be combined? Right. Well, the x is squared. We've got an x squared on x and a constant. None of that can be combined. So this, children, is our solution.
Wait. So you're telling me I thought that 2 was separate from the x, or is it? Or are they all together?
The 2 and the x are being multiplied together. 2x means 2 times x. So
Then why can't we multiply it by or add it by 4? I'm just curious. I know what I'm doing.
oh, because there's, remember, terms are separated by pluses and minuses. So 2x squared and 4 are different terms. The terms have to be the same for us to combine them. If we wanted to combine the 2 and the 4 together, there would have to be a plus or minus sign in between the 2 and the x squared, like 2 plus x squared. Then I could combine the 2 and the 4 because the 2 is its own term.
Well, I was, because like my old school, we did pre-algebra.
Mm-hmm.
And they would, I don't know what it's called, but you do some equation that has 4, numbers or letters, whatever.
Mm-hmm.
bring it down and group it with something else that is like alike, you know what I'm saying?
Yes, if they're alike, you can do that. But alike means they must have the same variable to the same exponent.
Oh, yeah.
Since the first term here has x squared and the last term's got no variable at all, those are unlike terms and I can't combine. Now, I think the hardest part of this problem is actually the very first step when we wrote out the stuff that we were going to multiply by. This step right here, I think that's the hardest step. So I want to show you another method. We're going to do the exact same problem. I want to show you another method that can help you stay organized. My true passion in life, organizing things. Help you stay organized to make sure that when you're multiplying, you don't mess up on that step, which is definitely the step you're most likely to mess up on. Now, this is a binomial multiplied by a binomial. It's two terms multiplied by two terms. So I'm going to draw a square that is a 2 by 2 square. That's a 2 by 2 square right there. And it's a 2 by 2 because it's a binomial times a binomial, or two terms multiplied by two terms. My first binomial is 2x minus 1. So across the top of this square that I drew, those two spots at the top, I'm going to put the 2x minus 1. The second binomial that I have, x minus 4, is going to be written along the left side, x minus 4. Now, the way I fill in the squares is exactly the same as the way you fill in your Punnett squares in your biology class, which is that in order to fill in this square right here, the top left square, I do 2x multiplied by x. 2x times x is 2x squared. To fill in this square, the top right square, I do negative 1 multiplied by x. What's negative 1 times x? Negative x. To fill in this bottom left square, good, I take the 2x and I multiply by negative 4, which gives me, as Shelby said, negative 8x. And then the last square right here will be a negative 1 multiplied by a negative 4, which is a positive 4. You will notice that the four things that ended up in this box are the same four things that we got when we did the distributive property up here, which is that we have a 2x squared, a minus 8x, a minus x, and a positive 4. So by drawing this box in order to multiply the polynomials together, we end up with the same answer, but we do it in a way that makes sure we do the distributive property correctly. You'll know you're finished when all the boxes are filled in. All the boxes aren't filled in, you still have some multiplication to go. And just like before, those two terms in the middle can be combined. Negative 8x minus x is still not negative 7x. And there is our solution.
Basically, whatever the squares are like your main numbers, what you need. Like you need to have the equation, and then from there on, you write down those numbers and add them together. And then continue.
Yes, in fact, I'm going to give you one more of these so you can practice using the square. Now, some of you are looking at this square and thinking, you know what, if it's a binomial multiplied by a binomial, I don't know that I really need to go through the trouble of writing out that square. And you may be right. But what are you going to do next time we do algebra whenever I give you like 4 terms multiplied by 5 terms? That is not a super fun distributive property problem to do. 4 terms times 5 terms gets pretty uncomfortable. And in that case, making a table really does improve the quality of your life substantially. We're just doing binomial times binomial today, just to ease you into it. But as with most things in life, it gets worse. Think of binomials multiplied by binomials as Australian wildfires, and tomorrow we'll have the murder hornets. I mean, the tarantula hawks.
You skipped February.
I thought the murder hornets were February.
Murder hornets were March.
I thought March
No,
was
COVID was March.
COVID was March.
And then it was murder hornets was April.
Oh,
What was February?
Valentine's Day, the worst. Alien videos. I must have missed the alien video. Okay, so this is a binomial times a binomial, so we make our 2 by 2 square. So we do negative 2v, or not 2v, and then a positive 1. And then we do 3v and negative 5 along the side. So our first binomial across the top and our second binomial across the side. If you're wondering, does it matter if I do the first binomial on the side and the second across the top? The answer is no, it does not. Just like the rest of life, your decisions are irrelevant. The slow, inexorable march goes on regardless of what you do.
We're multiplying all these, right?
Yep, we're multiplying. So negative 2v, or not 2v, times 3v gives us, I like negative 6. I don't like v. Negative 2 times 3 is negative 6, but v times v is not v. It's v squared, or not v squared. Oh my. Then we do 3v multiplied by 1. Hold on, 3v times 1. 3v. Because anything multiplied by 1 is itself.
3 times 1 is 57.
I'm gonna teach math to these kids, I swear. Then we do negative 2v times negative 5, positive 10v, because negative 2 times negative 5 is positive 10. And finally, 1 times negative 5 is, somebody with a calculator, 1 times negative 5? Thank you, negative 5. So what do we end up with? Well, we got a negative 6v squared and a positive 3v. And then we have a positive 10v and a negative 5. Looking at this expression that we wrote, is there anything that can be combined? Yeah, we got some v's. That's going to give me, very good, 13v, or not 13v. Can anything there be combined? Yep, I'm going to tell you the same thing that every girl told me when I was in high school. Nope. The end. Now, I need to show you one more thing. We're not going to do the whole problem, but I need to show you a problem that can look a little weird. Hold on. Shelby, can you just turn around? I'm going to draw a picture of you real quick. Can look really weird.
You could just draw Arthur Morgan.
Okay. Now I just want to take a moment. Just a moment. I'm going to show you one of my biggest pet peeves in the whole wide world. I don't really have pet peeves so much as I have major psychotic hatreds. If you look at this problem, 7x plus 2 squared, and you look me in the eye and you tell me that it's 7x squared plus 2 squared, it's on. I'm coming for you. I'm coming for your whole family. And I won't stop until everyone you love knows that this is wrong. This is wrong. This is like taking your cousin to the prom. It's wrong. R-O-N-G, wrong. 7x plus 2 squared.
Unless you live in Lano County.
Oh. When you have something that is squared, it does not mean square all the stuff in the parentheses.
Oh no, you said square it with something that is
Squared means multiply it by itself. 3 squared means 3 times 3. X squared means x times x. Some parentheses squared means parentheses times parentheses. It's not 7x squared plus 2 squared. It's 7x plus 2 squared. The whole set of parentheses multiplied by the whole set of parentheses.
Shouldn't that be two squared though?
Oh, I get it now.
What?
I think you messed up. I think you meant to put 2 in that second one. You put
Never
7
mind.
X's in.
I was looking at it backwards.
Oh, no, never mind that. You guys do that.
Can you explain to us what are you looking at?
The parentheses was 7x plus 2 squared. So I did 7x plus 2 times 7x plus 2. It was little yellow highlight squared. So I did yellow times yellow. Yellow squared equals yellow times yellow. So now I could make my box here. And my box would have 7x plus 2 on the top and 7x plus 2 on the side because the set of parentheses was the same both times. Do not say, oh, just square both things in the parentheses. And I can prove to you that that doesn't work using my usual flawless logic. 2 plus 7 squared is not 2 squared plus 7 squared. 2 squared plus 7 squared is 4 plus 49, which is 53. That is not the correct answer. Because my dear Aunt Sally says, do parentheses first. It's 81, not 53.
49x squared.
Yes? Oh, she's solving it. Oh, here we go.
Why would you solve the monstrosity?
I think you participate more in classes you aren't in than classes you are in.
And then it's 14x. And then what's negative 14x?
Nope, no negatives because it's all pluses.
Oh, I thought it was negative. My bad. And then 4.
Good. I said we weren't going to solve this one, but hey, if you want to solve it, don't let me stand in the way of your dreams. We're not going to solve this one unless you're into it. What's 14x plus 14x?
28.
Yep. So the answer is 49x squared plus 28x plus 4. And in the words of Martin Luther King Jr., that's the way, I like it. Not that Martin Luther King Jr., a different one.
Not the one that we get the day off.
Not the civil rights guy.
No, oh, Martin Luther. Oh.
Really was a guy named Martin Luther. I think he was the founder of the Lutheran religion.
Yeah. I'm sure there's a lot of guys named Martin Luther though.
Probably a lot of guys named Martin King. And I bet there's a surprising number of Martin Luther Kings. I don't know if there's too many Martin Luther King Juniors.
I mean, someone had to have done it after him though.
Can you just make your name Junior even if you're the first one? Like, can you just put that on your birth certificate?
You said your grandpa.
Like, your name is not Martin Luther King. Your name is Christian Garza. And you have a child, and you name your child Martin Luther King Jr. Like, can you just put, I gotta look that up. Can you just put whatever you want on a kid's birth certificate?
Yeah.
Like, it doesn't even have to be your.
There's like a rule or something where you can, like, if the name's too offensive.
Well, dang, now I gotta know.
Yeah, because that could be considered.
I might have missed a golden opportunity when I named my children. I could have just written whatever I wanted.
Yeah, because like if it's, I also think they let him. If the name is too controversial, then it becomes you can't do that. It's considered child abuse because it will be bullied so much. I don't remember what teacher it was, but I had a teacher who told me about a student that she had to call CPS on because of the way they spelt their name. In which it had a curse word in the name.
That was me. I told you that story. I can't believe you already forgot it was me. Does anybody have any questions about multiplying monomials by polynomials?
What was the kid's
I
name?
have a question about the kid's name.
Yeah, I don't remember what the kid's name was.
I'll take that as a no.